Hello everyone, myself Siddharth Kumar Jha, and today I am going to talk about model evaluation and tuning. So, in this lecture, I am going to cover like overfitting and underfitting, cross-validation techniques, and hyperparameter tuning like grid search and random search. Okay, so let's understand first like why evaluate models. Okay, like why we are evaluating it. Okay, so training accuracy alone is not yet enough. So the real life challenge, will it perform well or unseen data? Okay, so whether the performance will be good enough for the unseen data, this is the real life challenge. So overfitting and underfitting or poor hyperparameter choice lead to bad generalization. Okay. So moving towards the notepad and discuss these all things. So here we will understand why evaluate the models. Why evaluate models. Okay. So the first point is like training accuracy alone is not enough. Okay. So the real challenge, will it perform well on unseen data? So this is the question mark. So overfitting and underfitting or poor hypermeter choice lead to bad generalization. Okay, so these all are like why we are evaluating the models. So the key concept is training set. It is used to fit the model, and the validation set. It is used to tune hyper hyperparameter. Okay, and the test set is for final evaluation. So what are the analogy? So analogy is like the training equal to studying the from book, and your validation means practicing mock test, and your testing is like actual exam day. So I hope with the real life analogy, I want to explain these all things like what is training. So studying from the book, and the validation means practicing mock test, and like testing means actual exam day. Okay, so this is all about the analogy part. So without wasting time, just move on to the overfitting and underfitting concept. So before moving further, first, let's discuss from the slide model evaluation and tuning. So the purpose is like access how well a model generalized to unseen data. Okay, so the key metrics like accuracy, precision, recall, F1 score, ROC, EUC, and log loss. Okay, so it is importance because it prevents over optimistic performance due to overfitting. Okay, so let's discuss about overfitting versus underfitting. So overfitting means like a model learn noise and performance poorly on the test data and high training accuracy, low test accuracy. Okay, the training accuracy is high, but the test accuracy is low. Okay, I am clear. So moving further, the underfitting. So in underfitting, model are too simple and fails to capture the pattern. So low accuracy on both train and test set. Okay. So the goal is like to achieve balance and good fit. Okay. So the goal is like achieve balance. So I hope I am clear. So let's move to the notepad and understand it into detail. So let me write down the topic here also. That is overfitting and underfitting. Okay. So first we will discuss the underfitting. So it is a model in this the models are too simple and fails to capture underlying trends. Okay, and for example, suppose predicting house price with only a constant value. Okay, only a constant value. So I hope I'm clear with the explain example and the overall concept about the underfitting. So let's take some advantage and disadvantage from the underfitting and overfitting. First, we'll understand of underfitting. Okay, so the advantage is like very fast. It is very fast to train and it is easy to interpret, easy to interpret, and it is low variance. So these are some advantage, and along with the advantage, there are some disadvantage also. So the disadvantage are like disadvantage. So it is like very fast. Ah, sorry, we are talking about the disadvantage, no? So high bias, and poor accuracy, and the second one is like misses important pattern. I hope I am clear with the over underfitting. So let's moving further the next one, which is overfitting. Okay, so overfitting. So overfitting is like, let me change the pen. So overfitting is model is too complex, model is too complex, and memorize memorize जेडी होता है ना, memorize noise in training data. So in this, in the overfitting, the model are too complex and memorize noise on in the training data. So for an example, suppose decision tree with depth is equal to 50 fitting every training sample. Okay, so uh, decision tree with depth is equal to 50 fitting every training data or training sample. Okay, so the now we will talk about the advantage part. So the advantage of overfitting is like it is very high accuracy. It has very high accuracy on training data, and the next one is like it can compute or it can capture complex pattern. Okay, so these are some advantage, and if we talk about the disadvantage, so the disadvantage is poor test performance, poor test performance, and sensitive to outlier and noise, and the third disadvantage is like hard to interpret. So I hope this comes like it covers the basic advantage and disadvantage of the overfitting. So now we'll move further. Yeah, I have zoom out. Just take a snap for your further reference. So I hope you have done. So like we'll go to the next, which is your bias variance trade-off, which is your bias variance trade-off. So in this, the bias and variance, and we will talk about the total error. So the bias is like error from simply simplistic assumption. And if we talk about the variance, so variance is like error from sensitive or sensitivity to noise. So the total error becomes like your bias square, bias का whole square plus variance plus noise. Okay, so the goal is like find the balance, find the balance point, just right complexity. So this is about the bias variance trade-off, and we have discussed like the goal and what is bias variance and what is the total error. Okay, so let's move towards the solution portion. So what is its solution? So solution. So solution is like reduce underfitting. So for reducing the underfitting, the solution is like add features and use more complex models. And the next one is like reduce overfitting. The solution is like use regularization, use regularization and pruning and dropout and cross validation and collect or collect more data. So these are the solution to reduce the overfitting. Like first we have to use the regularization and then we have to use the dropout and cross validation or collect the more data. So this is solution for the overfitting, and the underfitting solution is like add features and use more complex model. Okay, so now we'll move to the cross validation techniques. So we will go to our slides and understand some key points, and then we will back to the notepad to understand it in detail. Okay, so I'm going to the slides now. So yes, now the cross validation technique. So the purpose is like for the better estimate of model performance. So the technique we can use is like k-fold cross validation. In this, we are split the dataset into k parts and train test into the k times. Okay. So the next one is like stratified k-folds. So in this, we are ensure like balanced class distribution. And the next one is like leave one out, which is LOO also. This is very important. So in this, each sample use one as a test set. So it helps to detect overfitting and underfitting reliably. Okay, so we are going to the so from this slide we have understand the cross validation techniques. So now we will go to the notepad and understand in it detail. Okay, so we have come to the notepad and going to analyze the cross validation technique. Cross validation technique. So, first understand like why cross validation is required. Why cross validation? Okay. So the first line is like a single train test split may be misleading. And for example, suppose if we split data such that the test set is very easy and model look better than reality. So in the cross validation, average result over multiple splits, like which is more reliable. Okay. So let me write down this point also. So in cross validation, average result over multiple splits is like tends to more reliable. So the next we will understand the method of cross validation. So methods of cross validation. So the method are like the first one is k-fold cross validation. So in this, the first point came is like data divided into k equal folds and then train on k minus 1, test on 1 and repeat k times. Okay, so it gives the average result. So in the k fold cross validation, we are like dividing the data into k equal folds and then train it on the k minus 1 and testing it on the 1 and repeat it for the k times. Okay, so it gives the average results. So let's move further. The advantage and disadvantage of k cross validation is let me write down the first advantage. So the advantage is like the first advantage, reduce variance in evaluation. And the second one is like every sample used for training and testing. Like we are not keeping it separate for the training one and the testing one. Okay. And the third point is like works well on moderate data set. So we have talked about some advantage. So there are some disadvantage also. So let me write the disadvantage. So the disadvantage are like computationally expensive for large K. If the key value is large, then computationally expensive and not great for highly imbalanced dataset, which is unless stratified. So the next method is like your stratified k-fold CV, stratified k-fold CV. So let's understand what it is. So preserve preserves classes, class class properties in each fold. So it prevents the class proportion in each fold and useful in imbalanced dataset like your fraud detection and your rare disease. Okay, so we have understand the stratified k-fold CV. So moving further, some advantage and disadvantage part. So if you will talk about the advantage, so the advantage is like fair evaluation across classes and it prevents model bias towards majority class. Okay, so there is one disadvantage also. So there is one disadvantage. That's why I'm writing in this slide only. So disadvantage is like slightly more complex to implement. So it is little bit complex to implement. So this is about the stratified k-fold CV. So next, we will move towards the leave one out cross validation. Okay. So the third one is like leave one out cross validation. So in this, each sample once as test and rest as training. So in this, the advantage is almost unbiased, like uses max training data each time, and great for very small data set. Okay, so next we will talk about some disadvantage. So the disadvantage is like extremely computationally expensive and the variance can still be high. So the next one, which is like shuffle split cross validation. So the next technique, which is shuffle, SSU develop is shuffle split cross validation. So in this, randomly splits multiple time, and it in this flexible control over size of train and test sets. So in this, like there is a data set. So we are randomly splitting into the multiple times, and it is flexible to control over size of training or testing sets. Okay. So let's talk about some advantage. So the advantage is like it can use larger training set, and the next is like useful for every for very it is useful for very large data set. Okay, so there is one disadvantage is like some samples may never be tested because we are choosing randomly, so there might be some data which is not tested. Okay, so let's do the comparison between all the techniques or all the method which we have learned for the cross validation. So in the next page, let me go to the next page. Let me make out one table in which some method name is there, and advantage and disadvantage and best use case is there. So let me create one table first. Yeah, so it's created. So in this we will write like the first method, which is train test split. Train test split. So in this, its advantage is like fast, it is fast and simple. And the disadvantage is like high variance in result. And it is best for use like in the large data set. Okay. So the next one which we have learned the method is like k-fold cross validation. So it is balanced and reliable. And the disadvantage is like expensive for large data, and the best use case is like on the general data set. So the next one which we have learned about the stratified k-fold. So in this it handle imbalanced data and it is slightly complex, and the best case is like imbalance classes. So the next one, which we have discussed about the LOOCV. So in this, the maximum training use. In this, the advantage like we are maximum data using in the training use, and it is very slow. It's disadvantage, very slow, and it is used for like small data set. And the last one is like last method, which we have learned about the shuffle speed. So in the shuffle split, the advantage is like it is flexible, and disadvantage is like some sample is unused, and it is best used for the big data. So now we have compared all the methods for the cross validation, and we have seen some advantage and disadvantage, and in which case it is best used. Okay, so now we will discuss about the hyperparameter tuning. So let's go to our the slides and we'll discuss here, and then we will come back to the notepad for in the detailed discussion. So in hypermeter tuning, there is two search is come, which is very important. The first one is like grid search, and the second one is like random search. So in the grid search, in this, what we are doing, like we are doing the exhaustive search across the predefined parameter values to find the best combination, but computationally expensive. Okay, and in the random search, we are like randomly samples combination, and it is faster and good for large parameter space. So the best practice for this is like use cross validation with tuning. So let's going to the notepad and understand in the detail. So let me make the topic name first, hyper parameter tuning. So the first one is like we have to understand the parameters versus hyperparameter. This is parameters versus hyperparameters. So the parameters is like learn from data, which in the data it learn from the weight and coefficient, and in the hyperparameter uh, set before training. So it learned it, and maximum depth it learning rate and max depth. Okay, so if the wrong hyperparameters is there, so it leads to the poor model performance. So note note point, if wrong hyperparameter are there, then it leads to the poor model performance. Okay, so the next one is like grid search. So let me go to the next page. So the next one is like grid search. So in the grid search, it tries all possible combination from a predefined grid. So for example, suppose learning rate is equal to like 0.01 or zero point 0.1 or 1. You have given. So and the max depth is equal to, you have given like 3, 5 and 7. Okay. So the total combination is which can be like 9 total combination which can be made. Okay. So I hope how we are getting the 9 total combination, like 3 for 0.01, 3 for 0.1, 3 for 1, and like on. So 5 for 0.01, for 5 for 0.1, and 5 for 1, like that. Okay. So total 9 combination will be created. So now talk about the advantage and some disadvantage of grid search. So the advantage. So the advantage is like systematic and guarantee to find best inside grid, and it is easy to understand. And the disadvantage of this is like it is very slow for large search, and it may miss uh, optimal values outside the grid. Okay, so the next one is like a random search. So we'll talk about some random search. So in this randomly samples hyperparameter uh, combination. So in this like randomly samples hyperparameter combinations are happen. So if you talk about some advantage and disadvantage, so advantage. So the advantage for this is like much faster, and the second advantage is like covers wide space quickly, and wait, surprisingly effective. So the disadvantage are also there. So there are two disadvantage only. Disadvantage. So the first one is like it may miss best combination, and the results vary run to run. Okay. So the next one is like advanced mention. The third one is like, sorry, fourth one, no? Advanced mention. So, which is like Bayesian optimization. So, in this, like smarter search, we are doing using probability model. Okay, and there is one hyper band. So, in the hyper band, like uh, early stopping, अरे यार, early stopping, poor model, and the generic algorithm. The third one is like generic algorithm. So in the generic algorithm, evaluation evaluation is like inspired search. Evaluation based on the inspired search. Okay, so let's do the comparison of all the things which we have learned, like grid search, random search, and Bayesian optimization, hyperband, and generic algorithm. So let me make a table. So we will write like method and advantage, disadvantage, and best use case. So the table is ready. Let me fill out the content. So in the method, we talk about the grid search. So its advantage is like systematic and and reliable. And the disadvantage is like slow and expensive. And it is best used for the small parameters space. Okay. So the next one is random search. So in the random search, it is fast and scalable. And the disadvantage like memes, optimum, and it is large parameter space used for large parameter space. So it is fast and scalable, and meme is some input data or important data which is required, and it is based for the large parameter space. And the third model is like your Bayesian optimization. So in this, it is efficient and smart. If sorry, efficient and smart, and it is more complex, and it is used and best is used for like expensive models. So the next one is like hyperband. So in the hyperband, it saves time and it is complex, and the natural net, it is like the best use case. And the last one, if we will talk about generic algorithm, so in the generic algorithm, it explores well, and the disadvantage is like complex and it is slow, and the best use case in the field of research. Okay, or you can say some experimentation, it gives the best result. Okay, so I am zooming out to just take a note. Okay, so the key takeaways we have gone through today. So first one is like what is overfitting and what is underfitting. So if you talk about the overfitting and underfitting, so models must balance, and complexity is based on the bias variance trade-off. Okay, and next one we have talked about like the cross validation. So it ensure reliable evaluation, avoid misleading results. Okay, and next we have seen about the hyperparameter tuning. So it is crucial for performance, and a grid search, which gives like systematic versus random search, which is efficient. So a model that memorize is not intelligent. A model that generalize is by applying cross-validation and hyperparameter tuning. We transform ordinary models into reliable production and ready system. So this is all about the today video. So in this video we have learned so many concepts. So in the next video we will come with some new concept of the machine learning. Till then, keep learning and keep exploring. See you in the next video. Bye bye.